Hello everyone, this is Raymond Burchard. This is my progress report for climate control for plant cabinet project for EET 2974 capstone project. In this presentation, I'll be going over the definition and objectives of the project, how my proposed system is designed. I'll touch briefly on the components that I need, the budget up to this point, and the standards and constraints, as well as the project steps and hurdles. I have a timetable that shows how the project is coming along, and I'll discuss the next steps for the project. For this project, I'll be making a system of circuits that help keep the climate inside this plant cabinet closer to optimal conditions. The reason I'm doing this is to increase the profitability of a small plant selling business. Better climate increases the health of the plants and the success rate of propagation. The system is divided into 4 parts. Each will monitor a different environmental factor. The final subsystem will be the logic system that will control the display for the other systems. The core of the temperature system will be this W1209 digital thermostat. It has the benefit of an electrically isolated output, which means I can use any other voltage inside the switched portion of the circuit. The set point is fully adjustable with a greater than set point and a less than set point for the switching function. It does have a digital display that I have decided not to use. For the humidity system, I'm using a single LM339 op amp to switch between 3 LEDs depending on the output voltage of an HIH4030 humidity sensor. My current design will have a red LED for humidity 10% to 45%, a yellow LED for humidity 45% to 75%, and a green LED for humidity over 75%. I might decide that I want to add a different range, but right now I think that this will do what I need it to do. For the soil moisture system, I'm using a 555 timer to test the resistance between 2 test probes in the soil. The 2 LEDs will flash back and forth depending on the moisture level. The more moisture, the faster they'll flash. As the soil dries out, the flashing will slow down. This will be an excellent tool for creating soil compositions that have appropriate drainage. The logic system will use logic gate integrated circuits to show a warning if conditions inside the cabinet are incorrect. I'm considering removing this system from the project. The other systems do a really good job of displaying the information, so I may not need to have a centralized system. Also, the humidity system is 5 volts and the soil moisture system is 9 volts. I'm not sure that it's really worth the additional items I'd need to make these 2 systems come together in one system, so I may end up taking it out of the project. I originally decided that $200 would be the budget for this project. I wasn't sure how much some of the components would cost. So far, everything in the table is what I have in using right now, and I'm really under budget, so I'm doing a pretty good job there. I still need to get a layout for the box I'll be putting the circuits in. This will be the last component that I have to purchase unless I make a change somewhere. I am waiting on resistors and the humidity sensor for the humidity system. For some reason, the humidity sensor has a long lead time, but it should be here early next week. To implement the project, I don't have a whole lot more to do. I need to finish the circuit design, including if I want to keep the logic system or not. I need to finalize the display box and then install the probes into the system. I've been working on looking up information for the NFPA 70E electrical safety standards to make sure that I'm following any standards that apply. I am concerned that my circuits are going to be larger than what I would like. I was originally going to put the circuit boards on a permanent prototyping board, but I'm not very good at soldering, so I've decided that I'm going to go with a miniature breadboard instead. It's working really well, but the system is going to be larger than what I originally anticipated. I've discussed that the logic system may not work how I would like it to be, so I may have to take that out. I've gotten a little bit behind with this project. I've had a lot of overtime recently, and I wasn't able to keep on top of it as much as I would have liked. I'm still on track for finishing, but just a little behind in finalizing the circuits. This is where I'm at with the project. I'm pretty pleased with how things are coming together. I like the way that the soil moisture sensor works. I wasn't originally thinking about using it to help with mixing soil, but it'll be a really useful tool. My next step is to test the humidity sensor when the parts come in and add the final touches to the system. That's all. Thanks.